Welcome to Section 2, S3 and EC2 Exam Prep. In this section, we will have an EC2 recap of instance types in EBS, as well as an S3 recap about object storage, lifecycling with Glacier, storage types and version control, some exam tips, as well as a summary and quiz. EC2 recap, instance types in EBS. We will have an EC2 recap, focusing on instance types, EBS volume types, as well as user data, metadata, and ELBs. We will now go through the EC2 types that are available. We talked about the T2 family, which is for general purpose and allows for bursts. This is especially useful for when you create dev environments and very small web applications to test your code out. M4 is for general purpose, and this is more of a production type of instance that you think about using. Example use cases include small and mid-sized databases as well as application servers. C4 is compute optimized. Think about using it for applications and databases with high CPU requirements. R4 is memory optimized, and think about using it for applications and databases with high memory requirements. X1 is memory optimized, and think about using it for SAP HANA, Apache, or Presto types of applications. P2 is general purpose GPU compute applications. Think about using it for machine learning as well as performance databases. G2 for graphics intensive applications, 3D application streaming and video encoding. F1, think about FPGAs, using this type of instance for genomics research or financial analytics. I3 is storage optimized, think about high input-output for NoSQL databases, in-memory databases, and data warehousing. And the last family is storage optimized with dense storage, or D2. Use it for massively parallel processing or MPP data warehousing, or Hadoop or distributed file systems. Next, we spoke about EC2 pricing plans. There are currently 4 different pricing plans. First of all is on-demand, and you would think about using on-demand for short-term and spiky or unpredictable workloads that cannot be interrupted. For example, if you're going to have a new launch of a product, you would think about using on-demand to scale out your applications. Spot instances are a way to allow you to bid on spare EC2 computing instances. Think about using spot instances for applications that have flexible start and end times and that are feasible at a very low compute price. So think about possibly using spot instances for big data analytics, anything that can be interrupted and restarted. Then we have reserved instances. This is for the case where you know you have a certain workload for your applications and you don't expect a sudden increase in demand. So you would reserve an instance and it would work out cheaper for you in the long term. You could either reserve it for 1 or for 3 years. Then there are dedicated hosts, which allow you to meet compliance requirements where you cannot have a shared hosting or multi-tenant virtualization. What you need to remember about spot instances is that if AWS terminates your instance, and they will give you a 2-minute notification before they do that, you won't be charged for that particular hour. But if you terminate your instance yourself, you will be charged for the full hour. Think about using instance store volumes only for temporary storage. Then we move on to EBS volumes, which are persistent blocks for storage. Then you have to think about whenever you have an EBS volume, it can only be mounted to 1 instance at a time. You cannot have 2 instances sharing the same EBS volume. To do that, you would need to use EFS. There are 5 different types of EBS volumes available at the present. First, there is general purpose SSD or GB2. You would think about using this for up to 10,000 IOPS. It offers you a very good price and performance ratio, and is recommended for most workloads. Then there is provisioned IOPS, which offers the highest performance for SSDs or any other types of volumes that are available in EBS, but provisioned IOPS are SSDs. And think about using provisioned IOPS when you need between 10,000 and 20,000 IOPS. And they are especially very useful for latency-sensitive applications. Then there are magnetic types EBS volumes. Think about using them for infrequently accessed datasets. They are on HDD, but all of the general-purpose SSDs, provisioned IOPS, and magnetic volumes are all bootable. So you can stop and restart the instance and there will not be any issues with your data. Then you have throughput optimized for frequently accessed data, and cold HDD, SC1, less frequently used workloads. The last two are both HDD and they are not bootable. You can attach an EBS volume or instance store volumes. You can attach EBS and instance store volumes before you create an EC2 instance, but after you have created the EC2 instance, you can only attach EBS volumes. Root volumes are not encrypted. You would need a third-party tool by default. You have the option to encrypt additional volumes. The root EBS volume is by default deleted on instance termination, but you can change that if you want to. Termination protection is by default disabled, but if you enable it, you will prevent users from accidentally deleting your EC2 instance. Then we talked about snapshots. Snapshots are copies of EBS volumes and are stored on S3. They are incremental backups, that is, only the blocks that have changed since your previous snapshot are saved to S3. Only the data, if you decide to delete a snapshot, only the data that is unique to that particular snapshot will be deleted. Snapshots of encrypted volumes are encrypted automatically, and volumes from encrypted snapshots are encrypted automatically. If you decide to copy your own unencrypted snapshot, you have the option to encrypt your snapshot. Then we can create an AMI from our EBS volumes. We've seen that in our lab. But first, an EBS snapshot would be created in the process. It is recommended to shut down your instance before taking snapshots of root EBS volumes. You have the option of no reboot. Your instance would not be stopped while the snapshot is being taken. If you have an application writing to your EBS volume while the snapshot is taking place, you will have no guarantees around the image's file system integrity. The snapshot could be completely out of date or it could capture some data that is not very consistent. So that's why it's recommended to shut down your instance beforehand. By default, AMIs can only be launched in the region that they were created in. And if you want to launch your AMI in a new region, you would copy the AMI over to the new region. Then, we can talk about the information about the instance. First of all, we have metadata, which is information about the instance. For example, local IP, the instance ID, the AMI ID, the availability zone that the instance is located in. And you would find that information out by going directly on your instance to http 169.254.169.254/latest/metadata/. And there is the concept of user data. Think about it as scripts to configure the instance only at launch time. And to actually retrieve the script that you've used beforehand, you would go to http 169.254.169.254/latest/user data, but you would only be able to view the launch script if you have anything. Otherwise, it's going to return nothing to you. Then we talked about ELB, or the Elastic Load Balancer. It stops serving traffic to unhealthy instances. It supports HTTP and HTTPS. It gives you its own DNS name once you have created it. There is no IP given to you. You can only use the DNS name to connect to it. think about using application load balancers for HTTP and HTTPS. Then we talked about session state. The recommended way of maintaining session state is to use Elasticache for session data rather than using load balancer cookie stickiness or application generated cookie stickiness, because as we've seen beforehand, there could be the chance that the user gets redirected to the same EC2 instance over and over again, and you won't be able to scale out the application because most of your traffic could be redirected to one particular instance rather than having the traffic distributed to all the available instances. Then ELB, as we've seen, it can integrate with autoscaling groups, so new instances are automatically registered with the ELB. We've seen that in our application demo in course 1. Then we spoke about the AWS CLI. We've seen that it defaults to using the North Virginia or US East 1 for S3 operations. If you don't change it, it's going to use US East 1. If you do change it, it's going to use the region that you've chosen. Then some CLI commands that you should remember for the exam, but I recommend that you go through the link that I've posted below. So we have AWS EC2 run instances, which is the command to actually create a new instance. AWS EC2 start instances is to start a stopped instance. For reboot instances, just to reboot instance. Stop instances, it stops an instance. And terminate instances, it actually goes and terminates your instance. It's very important to remember the difference between run instances and start instances. So run instances is for creation, and start instances is to start an already created instance. Then we need to remember AWS EC2 attach volume. It allows you to attach a volume to a running EC2 or to an EC2 instance. Then we have AWS EC2 attach volume, which allows you to attach an EBS volume to your instance. Then AWS EC2 create volume to create a new EBS volume. AWS EC2 create image to allow you to create a new AMI. AWS EC2 copy image to copy your image over, for example, to a new region. AWS EC2 describe images shows you the available AMIs and details about them that you can use to launch new instances. And then there is AWS EC2 describe instances, which gives you information about the instances that you have enabled, that you have created. That is it. Join me in the next one.